Howdy! This is your friendly neighborhood physics teacher here, and we're going to talk about free body diagrams. Okay, so with free body diagrams, what these are is to help you visualize what forces are affecting one object. Okay, free body diagrams is to see what forces are affecting one diagrams. Now there is a force diagram that you can do that will do all the forces in a situation, but those tend to get people confused, so we just focus on free body diagrams. And you might see me just put them as free body diagrams. If you see FBD, free body diagrams. You can get all fancy and draw, like if we're talking about a car, you can get fancy and draw a car. If we're talking about a flower, get fancy and draw a flower. But honestly, you don't have to be fancy at all. You can just draw a box. Most of the time, if you're having to draw a free body diagram on a free response question, they'll give you a box and tell you to draw forces on it. So you have a box. All your forces have to come from the center of mass. So all your forces are going to come off where the center is. So if you want to draw a little dot and be like, center. Now, they're not going to sit there and measure and make sure if you're direct center, because I know mine's off a little bit. But what forces are affecting this box can always come from the center. And then you just start labeling forces. So we're going to go back to our little thing talking about recognizing forces, and we're going to list all the potential forces. So force that's always there is force of gravity, or you can call it weight. Force, gravity, weight, same thing. I tend to lean towards force of gravity, but just know that force and weight are the same thing. Then you have your force of normal. Then you have your force applied. Then you have your force of friction. You can even take it a few steps further and saying your force of tension, or let's see here, trying to see what color I haven't used. I'm trying to get or force of spring. So make it a little bit thicker. There we go. Force of spring. So if we have a box that's just sitting there, what forces are acting on it? Hopefully you're like, force of gravity! Because force of gravity is on everything. And force of gravity points straight down. And you want to label your forces so you don't get confused. Now, the box is sitting on a floor or a table or something. Since it's sitting on something, it has a force of normal. And as we know it, those are the only two forces that are affecting that box. If a box is just sitting there. Now, we will learn in our next video that since the force, it's not moving, the forces are balanced. So the forces are balanced. And that means your vectors, because these are vectors, your vectors are the same length. So since the forces are balanced, your vectors should be the same length. Because your length is the same thing as your magnitude of your force. Now remember, magnitude is just the number. So think about force of gravity was 10, the length would represent 10, so your force of normal would be 10. And then, of course, the direction, there's an arrow pointing the direction. So your force is a vector because it has magnitude and direction. Okay. So let's think of another situation. Let's think about a moving car. So again, we're going to be very simple. You know what? No, I'll bring sombrero car into the mix. Sombrero car. Doo-doo-doo. Okay. So again, anytime you draw free body diagrams, you go from the center. And sombrero car is moving. Okay? So again, hopefully, you're like, force of gravity. Force of gravity goes down. The tires are sitting on the ground. So no, you're not going to sit here and draw a force of normal for each tire. You're just going to draw one force of normal going up and pretend like it's a straight line. And that's your force of normal. Again, you want to eyeball it that your force of normal and force of gravity are the same length because it's not moving in the y direction. We don't have hovering cars yet. Gosh darn it. So since our force in the y direction is 0 newtons, that means that pretty much our force of normal equals our force of gravity. Okay? So their lengths need to be the same. So length, it's got to equal the length of gravity. Again, they're not going to take a ruler and measure it. It just needs to be close. Now we do have, let's see here. Oh, no, force of normal should have been orange this whole entire time. But it should be just easier to switch this than to switch everything. So we're going to try to say force of normal is white, and force of friction is orange. There we go. Messed up my colorization right off the bat. Okay. But we do have some type of force applied. Force applied is pink. But it's usually the force of the engine making it go. But since it's moving in this direction, we have some type of force applied. The wheels are on the ground, so we do have some type of force of friction. If you notice, my force applied is not a whole lot longer, but is longer than your force of friction. Here, we will make it a whole lot longer, so it kind of stands out more. Car's moving fast. So all that's saying is that your force applied is stronger than your force of friction, which makes it because the car is moving in that direction. And this, it'd be accelerating in that direction, because your force applied is way bigger than your force of friction. Again, your free body diagram is just a way to visualize what's going on. Let's do another example. So if we have a box hanging from a ceiling. Yep, there's always a force of gravity. But in this case, we have a force of tension, which is light blue. Not moving, so should be the same length, or close to it. Let's say we have a box sitting on an incline. This is where it gets kind of interesting. So gravity, still going straight down. But your force of normal tilts with your... Oops, that's way... Trying to... The force of normal is perpendicular. having trouble drawing it. There we go. So your force of normal is perpendicular to your surface. It's a little off. And then to keep the box from sliding, you do have some type of force of friction, which would be going this direction, because it would be sliding down, and your force of friction always goes opposite of the motion. This is your force of normal. So you only do the original force. When we get into equilibriums, which will be our next video I'll do, that video we'll see that we have to break things down into our x and y component like we had to do for projectiles, but those are never part of the true free body diagram. So if it asks for a free body diagram, it just wants the original forces. It doesn't want like sub-forces or components. Yeah, so these are free body diagrams. Just a visual on what forces are affecting that object. That's all it is. Hope that helps explain what a free body diagram is. Have a wonderful day. Remember, you're loved and appreciated. Bye.